Hello everyone, we are going to discuss or solve few interesting questions, and these questions are related to circuit analysis, capacitance, resistance. Okay, and these problems are appeared in different physics exam like JEE Main, WBJEE, CBSE Board Physics exam, also in different years. Okay. So we will solve this problem step by step. Okay, now in the first question we are asked to solve in this given circuit when current becomes constant, what is the charge of capacitor C. Okay, and this has appeared in JEE Main 2017. Okay, so when current in the circuit becomes constant means capacitor basically act as like a resistor of infinite resistance. Okay, at that time no current will flow through this capacitor. Okay, so this is the solution. So in this capacitor no current will flow. So using Kirchhoff's second rule in this Kirchhoff's second rule in this closed loop, we can find out the current in the given circuit. Okay, and to find out the charge in the capacitor C, we need to find out the potential difference between two plates of the capacitor. Okay, and potential difference between two plate of the capacitor is basically VPQ. Okay, and as no current is flowing through this R1 also, so VPQ is equal to VPM. Okay, and it is as usual to see to see this problem that VPM is equal to VAB. Okay, potential difference between this P and N point is basically potential difference between A and B point. Okay, so VAB is equal to I into R2. Okay, so potential difference between two plates of the capacitor is VPQ is basically VPQ is equal to VAB, I into R2. Okay, so C is equal to Q by V. From this equation we can find out Q. When current in the circuit becomes constant, charge of the capacitor. So from this equation we can find out the charge of the capacitor C. Okay, so firstly we are calculating current, and then we are calculating the potential difference between two plates of the capacitor. Okay, that is basically VPQ, and in this case VPQ is equal to VAB. And from this equation we can find out the Q. Okay, charge of the capacitor. Good. So in this question we are asked to solve when no current is flowing through AO, find out X and then resistance X, and what is the current flowing through battery. And it has appeared in CBSE 2002. Okay, it is not difficult basically. So the upper portion of the circuit we can think like a Houston bridge. Basically, as no current is flowing through the wire AO, we can think as like a Houston bridge. So upper portion, from the upper portion of the circuit, using this Houston bridge equation P by Q is equal to R by S, we can find out X, unknown resistance. Okay, and as no current is flowing through AO, we can analyze this circuit in basically in this form. And these two resistors are present in series, and these two resistors present in series. Okay, so and these two are in parallel. So from this equation, using Kirchhoff's second rule in this closed loop, we can find out I. Okay, current flowing through the circuit. ठीक है? Next question. It is an interesting question, and it has appeared in WBJEE 2017. Okay, we are asked to solve VBC, potential difference between C and B point in this circuit. Okay, we can use same theory in this problem also. No current will flow through this capacitor. These capacitors are basically act like a resistor of infinite resistance. Okay, so using Kirchhoff's second rule in this closed loop A, B, D, Q, P, A. Okay, we can find out the current flowing through this circuit, and no current is flowing through this capacitor. Okay, and we have to find out VBC, potential difference between these 2 points. Okay, and another thing is that these two capacitors present in series. Okay, so charge, if we assume charge of each capacitor is Q, so charge of both capacitor will be Q. Okay, and what is VAD? VAD is basically potential difference between 2 points A and B, that is I into 1 plus 2. Okay, that is a VAD. And charge of first capacitor is Q1 and charge of second capacitor is Q2. As these two capacitors are present in series, so Q1 is equal to Q2. And we can find out VBC by this equation. Okay, what is VAD? VAD is equal to Q by C1 plus Q by C2, as C is equal to Q by V. VAD is equal to potential difference between two plates of each capacitor plus potential difference between two plates of these capacitors. Okay, so VAD is basically Q by C1 plus Q by C2. Okay, and VAD is equal to this. Okay, this will be 3 by 2 volt, not ampere. Okay, and from this expression, by equating this VAD is equal to this, we can find out Q, charge of each capacitor, and that is 1 microcoulomb. Okay, and we have to find out the VBC, VB minus VC. So first we have to calculate the potential difference between two plates of first capacitor, that is VAC. Okay, what is VAC? VAC is equal to Q by C1, and what is VAB? V is equal to I into 1. Okay, that is just simple. One by one we can calculate these parameters VAC, VAB. Okay, not parameter, this is voltage basically, potential difference between 2 points of the circuit. Okay, and what is VBC? VBC is equal to, using this equation VAC minus VAB, we can find out VBC is equal to 0.5 volt. Okay, okay, that is good, and it is an interesting question basically. Okay, it has appeared in WBJEE 2017. Okay, we are calculating this problem step by step. We are equating VAD is equal to this. From this equation we can calculate charge of each capacitor, and we also find out the potential difference between two plates of the capacitor, that is VAC, and we also calculate the VAB, potential difference between two plates of the capacitor, and just VBC is equal to VAC minus AB. Okay, good. Next question, we are asked to solve VAB, potential difference between A and B point. Okay, so this is not difficult basically. Total current in the circuit I will be split in I1 and I2. Okay, and using Kirchhoff's second rule, along this closed loop we can find out I1 and I2. Okay, so what is VB? VB is equal to I2 into 3. Okay, and what is VA? VA is equal to I1 into 1. So from this equation you can calculate VB minus VA, that is VBA, potential difference between B and A point. Okay, just using Kirchhoff's second law basically. Okay, this is another question. We are asked to calculate the value of resistance R in the circuit shown in the figure. Okay, so that current in the circuit is 0.2 ampere. Okay, what would be the potential difference between points B and E? Okay, so calculate the value of resistance R in the circuit. We have to find out R basically, so that current in the circuit is 0.2 ampere. Okay, we have to calculate R firstly, and then we have to calculate what would be the potential difference between point B and E. Okay, so we are going to solve this problem step by step. We can solve this problem by hitting this circuit from right side. Okay, easily we can say that this current will flow, this 5 and 10 ohm are same, so these two resistors are present in series. Okay, so this will be 15 ohm, and this 15 ohm will be present in parallel in this 10 ohm resistance. So equivalent resistance between these two is 6, and this 6 ohm is parallel to this 30 ohm resistance. So equivalent resistance from this portion, from this circuit portion, is basically 5 ohm. Okay. Then the equivalent circuit will be this, and this is a closed circuit. Using Kirchhoff's second rule, we can find out R unknown resistance. Basically, they mention the current flowing through the circuit is 0.2 ampere. Okay, so if we take current is flowing clockwise, so negative sign is present in this battery in the current direction of the current. So this is basically my sign convention rule. Okay, this is -8, and in clockwise direction of the current, positive sign is present here. Okay, so this is +3, and the rest of this just I into R. Okay, from this equation I is equal to 0.2. We can calculate R unknown resistance. Okay, and also we are asked to solve the potential difference between B and E point. Okay, so VB minus V is equal to I into this 5. Okay, this is 1 volt basically. So this is not basically difficult question, and it has appeared in CBSE 2012. Okay, and we can calculate this problem by heating. We are calculating this R and potential difference between B and E. We can solve this problem basically by heating this circuit from the right side. Okay, ठीक है. So in all questions we are using Kirchhoff's second law. Okay, and using this Kirchhoff's second law we are calculating current, voltage, unknown resistance, potential difference between two capacitors. Okay, next. So I think this is the last question. Okay, yes. So we are asked using in this circuit using Kirchhoff rule determine the values of unknown resistance R in the circuit so that no current flows through 4 ohm resistance. Okay, when no current is flowing through 4 ohm resistance, we are asked to find out unknown resistance R, and also we are asked to find out the potential difference between A and D point. This A and D point. Okay, and this also has appeared in CBSE 2012. Okay, we are asked to solve this problem also. So we can use again Kirchhoff's second law. Using Kirchhoff's second law, we can find out this current and also this resistance also R also. Okay, so using Kirchhoff's second law in this closed loop, in this first closed loop named AFEBA. Okay, and if we take current is flowing in clockwise direction, we can find out current I. Okay. Okay, in the circuit EDCBE, in the second loop, and no current is flowing through this 4 ohm, we are calculating 0 into 4 here. We are writing 0 into 4 here. Okay, and in this circuit second closed loop, we are using again Kirchhoff's second law. Okay, and using as usual my sign convention rule, we can find out unknown resistance R also. So an interesting thing is that current is flowing through clockwise direction. Okay, in this first circuit, and also I am taking current is flowing through clockwise direction is positive in my case. So in the current direction, positive sign is present in this battery. So in the second loop, this is +3. But if current would flow in this wire, but no current is flowing through this wire. But if we assume current will flow this wire, current is flowing this wire, flowing through this wire, this direction of current is anti-clockwise. Okay, so positive sign is present in front of the current direction, but as current is flowing anti-clockwise direction, in our assumption, if current will flow through this wire, we are taking, this is -6. Okay, that is my sign convention rule. If you feel stuck to understand it, please ask me in comment section. Okay, this is my sign convention rule, and it is basically very helpful, okay, to not to misunderstand, okay, not for avoid confusion. ठीक है, so we can find out unknown resistance are using Kirchhoff's second law in the first closed loop and second closed loop. Okay, and what is VAD? We are asked to solve also VAD, potential difference between A and B point. This is just I into 1 and I into 1. Okay, just this using this equation, VAD is equal to 3 volt and R is equal to 2 ohm basically. Okay, so if you feel stuck with any problem, please send the problem to my mail ID. Okay, and to crack this JEE Main, JEE Advanced and WBJEE exam and to score a good result in CBSE physics exam also, you can also practice Ariant physics handbook. Okay, so time to progress. So goodbye.